question paper irukka? No problem, you can look at the book. So many are absent. I hope you're able to see the screen. So can you just give me 3 minutes time? I'll just be back. So try to answer this question. So what is the difference between dielectric and conductor? What is the dielectric basically? Okay. What is it? Okay. So what do dielectrics basically have? They have dipoles present inside them, whereas electric conductors have free electrons present inside them. So they support the opposed conductivity, here they support conductivity. This is known to us. Okay. Moving on to the next one. You keep reading the question. Figure shows the field lines due to a positive charge. Is the work done by field in moving a small negative charge from Q to P positive or negative? Think about this. What are the concept we need to apply? So what this kind of a problem, what comes to your mind? How did you know that? Okay.
And from Q to P means the discharge is going towards P.
Okay.
So it's given work done by the field.
Work done by the field. What did you say?
Sir, the discharge of fast charge, the discharge is going from Q to P means it is going opposite to that.
Okay. So is that the reason for work done? So what will be the reason you will write in the exam?
So the displacement is lagging between the force and displacement is 180.
180. Okay, all the reasons are right only. Okay, but generally when you talk about the work done will get stored in the form of potential energy, right? So work done when the charge moves from Q to P is, can I write it as UP minus UQ? Right? UP minus UQ now, can I write it as Q into VP minus VQ? And what is the direction of electric field? It is always in the direction of decreasing potential. So which one is we are having greater potential? 1 minute, wait. UP minus UQ. How will VQ be more? It's definitely not negative. Due to a positive charge is work done by the field in moving a small negative charge from Q to P. So work done by the field. So electrostatic force is in this direction. So it should be actually U cube minus UP. I'm sorry. So when you write this, Q into VQ minus VP should give you a negative value. So the logic is we are doing the work against the electrostatic force. The electrostatic force and displacement of the object are in opposite direction. So the work done is negative. That is one way. Or the other way of writing this is U cube minus UP, and you can write it as Q into VQ minus VP. So did you understand why VQ is less than VP? Distance is more, and direction of electric field is from higher to lower potential. Okay. So what is the shape of an equipotential surface due to a single isolated positive charge? So whether it is a positive charge or a negative charge, it is always set of spherical. It is concentric. Why? You're talking about the fact that the distance between the subsequent spherical surface is decreasing or increasing. Is that right? But what is the meaning of concentric? Centric is center. Con here refers to same. So all the spheres have the same centers. Distance between them might vary. That's a difference today. Okay. Distance between them is not constant. That keeps changing. Okay. So since it is equipotential surface, some more important points which I would like to recollect is, on an equipotential surface, when you do a work to move the charge from one point to another, what is the amount of work done? Zero. This is one kind of question they keep asking again and again. Second is about the direction of electric field with respect to equipotential surface. How are they? Electric field is always perpendicular to the direction of equipotential surface. It's the same. Okay. So 12th one. Calculate the potential difference and the energy stored in the capacitor C2 in the circuit shown in the figure. Given potential at A is 90 volt, C1 is 20, C2 is 30, and C3 is 15. Tell me. It is grounded. Okay. But for you to calculate the charge, you need to find the equivalent capacitance in the first place. So what are the equivalent capacitance? Can you do that and tell me first? So they are connected in series means what are they? How do you calculate equipotential? 1 by C1 is equal to 1 by C equivalent is equal to, yeah, please do it and tell me. 20 by 3. So here it is 20 by 3 means what is the charge supplied by the battery? So Q is equal to CV. So C 20 by 3 into V is 90. How much is this? 600. 600 watt microcoulomb. So 600 microcoulomb is the charge present on each capacitor. And what are they asking us? So you need to find the potential difference across C2. So V2 is equal to Q divided by C2. So what is Q? 600 microcoulomb divided by C2 is 30, 30 microfarad. So it will be 20 volt. For my satisfaction, can you calculate C1 and C3 as well? C1 30. Correct. So if you add everything, are you getting 90? So this is, yeah, coming to that. So now it is 20. Now since you know the capacitance of second capacitor and the potential difference across it, apply half CV square, tell me what that's. So energy across the second capacitor is half C2 V2 square, half into C2 is how much? 30 into 10 power minus 6 into V2 square is 400. This goes 15. 15 into 400 is 6,000. Correct? 6,000 into 10 power minus 6. That is 6 into 10 power minus 3 joule. So this is the amount of energy that is stored in C2. I hope it is clear. Right? Please make a note of it. Make it fast. Shall I proceed? So I want you all to solve this question. So read it carefully and then solve. There is a parallel plate capacitor. Each plate is of area A and the separation between them is D. Now they are charged with charges plus Q and minus Q on the two plates. They find the expression for the energy stored in the capacitor. So what is the energy stored? Half CV square. Right, but I should not write half CV square in this problem. Why? Because they didn't give us the capacitance of the capacitor, rather they gave us the charge that is stored on each plate and the area of each plate. Also, the distance of separation between them is given. So use that expression to find the value half. So U is equal to half CV square, right? Half into C is epsilon naught A divided by D into V is how much? Very good. So it is ED, right? Can I write it as ED square? So half into epsilon naught A divided by D into what is the electric field between the plates of the capacitor? Sigma by epsilon naught, and you have a D already square. But what is sigma? Q by A. So half into epsilon naught A divided by D into Q by A into D square. Can I do this? Edra? Sorry. So half epsilon naught A by D into Q square D square divided by A square into epsilon naught square. These two will get cancelled by this. This is gone. So Q square divided by 2 times epsilon naught A multiplied with D is the answer. Okay. Is it clear? So please make a note of it. Done? See, give 2 examples of conservative forces you can, gravitational force and electrostatic force. So what do you mean by conservative forces? Very good. Very work done a round trip is 0, and conservative forces are path independent. Work done by the conservative forces are path independent. This is a good one actually. Mark it as important. So how many of you did this problem? Got the answer? So how to solve this? The slightly of higher order thinking only. So in the following arrangement of capacitor, the energy stored in the 6 microfarad capacitor is E. So energy stored here is E. Find the value of the following. The energy stored in the 12 microfarad capacitor. So they want the answer to be in terms of E itself. How do we do that? First find the equivalent capacitance. So what is the value of C equivalent? 6 and 12 are in parallel. So it is going to be 18 and this is 3. So C equivalent will be equal to 18 into 3 divided by 18 plus 3. 7. Oh, 18 by 7. Okay. So 18 by 7 microfarad is going to be the answer. Return. Now what else are we supposed to do? Yes. That is right. But what is the value? What is the portion of the total voltage that is accumulated across 6 and 12? Did you guys understand what I asked? See, the total potential difference is if I take it to be V. They didn't give it. I'm taking it to be V. We know that across 6 and 12, if I call it as V1, and across 3, if I call it as V2, then V1 plus V2 is what is V. Now my job is to find what is V1. Okay. So total charge is what you want to find. So total charge will be C equivalent into V, that is 18 by 7 times V. Is that what you're saying? Yeah. Okay. Combined it is, yes. Okay. See, you're again unnecessarily bringing in the combined effect. So what are you going to with charge? You want to do it half QV? You'll calculate V. How? Can we reduce the number of parameters? Can we try reducing the number of parameters? Any other suggestion? What you're saying is right. 6 upon? Which one? How did he get 6 upon 6 by 7? Okay, Q by C. What is the value of charge there? Okay, 18 by upon 7 times V by 3. Okay, so you want to do, so it is 6 by 7 V. So this will be V by 7. Okay. So that is one way. Did anyone do it in another way? In any other way? That is right. So let me explain what has actually happened. So first we found whenever you have these kind of problems, the first thing you need to do is find the equivalent capacitance. Once you find the equivalent capacitance, mostly you will find the charge. Okay. So we know the fact that charge across the capacitors in series is the same. Okay. So we found the charge across the system of capacitors, which I'm using the word system of capacitors which are in series. Okay. So the combined charge across 6 and 12 should be equal to 18 by 7. And the charge across 3 microfarad should also be 18 by 7 times what? The total voltage that is being supplied. Okay. So what is V3? We know that Q3 is equal to C3 into V3. So V3 will be equal to Q3 divided by C3. So Q3 is 18 by 7 times V divided by 3. So it is 6V by 7. Okay. So if the total potential here is 6V by 7, then how much will be the potential here? V by 7. Accepted? Right. So what is given in the question? Half into 6 into 10 power minus 6 into V by 7 the whole square is equal to E. What did I do? So I applied the formula half CV square. So half CV square is equal to E means. So here it is going to be 3. So V square divided by 49 is going to be E by 3 into 10 power 6. So what is V square? 49 by 3 into 10 power 6. So wherever I find V square, I'm going to use this expression. Right? They're asking the energy across a 12 microfarad capacitor. For energy across 12 microfarad, half into 12 into 10 power minus 6 into, in the place of V square, I can use 49 by 3 E into 10 power 6. This and this will get cancelled. Now it is going to be 4. So 4 into, is this right? Oh, sorry, 6. So this will go 2. So 2 means, is it 98 E? That's a very, very high value. Did I make any mistakes? See, if the energy is E here, it cannot be 98 times at all. It's a very high value. Half CV square. Did I miss any parameters? One minute. C. C equivalent Is it 18 by 7 only? Like no calculation mistake. Okay. So it is going to be 18. Yeah, 18 by 7. So what is going to be the charge across the third capacitor? So what is the total charge supplied? Q is equal to 18 by 7 into V. Okay, this is also accepted where this is this V. Okay. Now charge across 3 is also 18 by 7 times V. So Q3 is equal to C3 into V3, which implies V3 is equal to 18 by 7 V divided by 3. It's 6 by 7. Everything is right only. So here it is 6 by 7 times V. So here it should be V by 7. Okay. So half into 6 into 10 power minus 6 into V square. V square divided by 49 is equal to E. Oh, I made a mistake there when I wrote for the 12. We actually got the answer. Unnecessarily, I'm doing this again. I'll tell you what mistake I made. So it is V square is equal to 49E divided by 3 into 10 power 6. So when I calculated the energy across the 12 microfarad capacitor, I wrote it as half into 12 into 10 power minus 6 into V square is, I wrote it as 49E by 3 into 10 power 6. No. Should I write it as V square? V square by 49. That is what I made. V square by 49 is what I should have written, because the potential across the 12 microfarad capacitor is also V by 7 only. Okay. So this will be half into 12 into 10 power minus 6 into 1 by 49 into V square is 49E divided by 3 into 10 power 6. Now I think it makes sense. So 6, 2, this and this will get cancelled. So 2 times E. Right. So 2E, they did it in a different method. The energy will be twice. It makes sense. But only across the parallel capacitors. Only across parallel it is right. C is square. It's directly proportional to C. Potential will be the same. That's right. You can do it. If at all you get the same question, complete the exam, you need not sit and solve this. You can directly say it twice. Serious? Or if you get it in MCQ also, I'm not sure of this year's pattern, you can directly write it as well. But I hope the method is clear. See, we could have done it even without finding what is at V by 7. The reason why I had to find the potential across each is because they asked about the 3 microfarad capacitor also. At the time, I'll not be able to solve without knowing the potential. Had the question been restricted only to 6 and 12, I need not use this much complicated method. What I could have told is, if I take the potential across this as V1, here also the potential will be V1. So I could have written half into 6 into 10 power minus 6 into V square is equal to E. Then I could have written like the same logic. Then it would have become half into 12 into 10 power minus 6 into V square would have been what? So since 6 became 12, it became twice. So answer would have been 2 times E. That's it. That's the logic. Purida. Okay. So using the same logic, can you find the energy stored in the 3 microfarad capacitor? You have already done the whole problem. Good. 54 by, but that 49 should get cancelled. It should not be there. That's the answer. So do it, no? Can I rub this part? Can I? Okay, those who are on, are you able to understand? You're so silent. So half into C3 is 3 into 10 power minus 6 into V3 is how much? V3 square is 36 divided by 49 into V square. But what is V square? So half into 3 into 10 power minus 6 into 36 divided by 49 into 49e divided by 3 into 10 power 6. So this and this will get cancelled. 3 and 3 is gone. 49, yes. It is 18e. Right? So here it is E, 2e and 18e. E, 2e. And they are asking what is the total energy drawn from the battery? Sum of all the energies. So 18 plus 2 plus 1 times E, which is going to be 21e. Shall I proceed? So define an equipotential surface. So it's an easy question. Draw an equipotential surface in case of a single point charge, set of concentric spheres. In the case of constant electric field in z direction, why the equipotential surface of in case of constant electric field in z direction, why the equipotential surface is about a single, okay. So actually it's two questions, they're combined. You need to draw the equipotential surface in a constant electric for an electric field which is existing in z direction. Constant means uniform. So for uniform electric field, what is the equipotential surface? It's planar surfaces. So the next question they are asking is, why does the equipotential surface about a single charge not equidistant? That's the question you told. It is not equidistant. So please make a note of this. So please make a note of this point. So they are not constant. Means as the radius is increasing, the radius will increase in accordance with the decrease in electric field. That's what happens. That is the keyword they expect. So write down this point. The equipotential surface due to a single point charge is represented by set of concentric spherical shells of obviously increasing radii. So they are not equidistant, and the separation between the equipotential surface will go on increasing with the decrease in electric field. Is it clear? So separation between equipotential surface will increase. And why is it happening? Because of the decrease in the value of the electric field. Why is it decreasing? Obviously, inversely proportional to R square. Right. Third one. Can electric field exist tangential to an equipotential surface? You know the fact that electric field and equipotential surface are always perpendicular to each other. Why? Because the work done by the electric field when moving a charge on the equipotential surface is always zero. Had there been a tangential value of electric field existing, parallel component, tangential and parallel component would have caused the object to move on the equipotential surface, which is not possible. Right? Yes. So what about the 17th one? So two charges 5 into 10 power minus 8 and minus 3 into 10 power minus 8 are located 16 centimeter apart. At what points on the line joining the two charges in the actually it is not in, is the electric potential zero? Okay, take the potential at infinity to be zero. So how do we do this? How many points will you get? Where will you get them? From where? Tell me one thing, whenever you have a system of this kind of charges, right? When will the potential become zero? So what are the preliminary condition? Both the charges are supposed to be opposite nature. Had the question been with charges of similar nature, nowhere on the planet you can find the potential to become zero. 1.2. You want me to repeat something? You want me to repeat something? No, okay. Somebody spoke like, what were you asking? Enna kettama? You what is the answer you got? From where? Maybe, yeah, that is right. So before that, if you have this kind of a problem, right, from where, so the point, the null point will be closer to which charge? The null point will be closer to the charge with the smaller magnitude. So here it is 3 into 10 power minus 8. Here it is 5 into 10 power minus 8. So if I take the point P here, the distance of separation between them is given as 16. So if I take this to be R, this is going to be 16 minus R. So what will happen is the potential due to the positive charge should be equal to the potential due to the negative charge for the net potential to be 0. So K into 5 into 10 power minus 8 divided by R should be equal to K into 3 into 10 power minus 8 divided by 16 minus R. I want you guys to make a note that I didn't put a minus sign here because the actual expression would have been plus minus is equal to 0. This would have been the actual expression. So I directly equated to save steps. Okay, K and K will get cancelled. 10 power minus 8 is obviously gone. So 80 minus 5R is equal to minus 3R, which implies 80 is equal to 2R and R will be equal to 40 centimeters. So 40 centimeters from where? But 40 is very high number. How will you get? Wait. While explaining, I changed the minus. No, I forgot to cancel it. It is 3R only. Yes, R is 10 centimeters. When you take it in between, you will get 10 centimeters. Correct only, no? So R is 10 centimeters. That is logically right. Right. What will be? Where will the other point be? It will be on the same side of both positive and negative charges. So if I take this distance to be R dash, then how much will this distance be? R dash minus 16. So 5 divided by R dash will be equal to 3 divided by R dash minus 16, which implies 5R dash minus 80 is equal to 3R dash. So 2R dash would be equal to 80. R dash is 40 centimeters. So 40 from where? 40 from the positive charge. So only thing is when you're telling the number, right, you need to write from which charge. You will get 2 points. R between the charges. R dash is from R dash is on the same side of both the charges. This is R dash. So this distance is R dash. So that's what I told. There will be 2 points where the potential is 0. Those are called as null points. Okay. So at that point, what will happen? The point will be closer to smaller, the charge with lesser magnitude. So it will be one point will be in between and one point will be on the same side. So 18th one. So they have explained what is series and parallel, that I've already run it, right? Capacity can be increased by connecting capacitors. So three capacitors have capacitance equal to 2, 4, and 6. They are connected in parallel. Calculate the effective parallel capacitance. Well, when capacitors are connected in series, dash remains the same, obviously. The plates of a parallel plate capacitor are 10 centimeter apart and have an equal area of 2 meters square. If the charge on each is 8.85 to 10 power minus 10, the electric field at a point. So if you take the electric field at a point, between the plates, will it be 0? No, it exists. It is sigma by epsilon naught. Outside the plates, will it be 0? Yes, it is. Between the plates will change from point to point. It's a constant value, sigma by epsilon naught. Between the plates, the value will be 25 Newton per Coulomb. You can check and see, it will not get, it will not be the case. So you take the formula of sigma by epsilon naught and check it, you will not get it. So 4 10 farad capacitors are connected in series. Calculate the equivalent capacitance. Obviously, it will be 10 by 4. So 10 by 4 is 2.5. That's it. So this one you can do it now. Derive the expression for electric potential due to an electric dipole at a point on its axial line. Can you do that? So what is the value, guys? Kp divided by R cube. So depict the equipotential surface due to an electric dipole. So electric dipole, again you will have something like this. In between, the equipotential surface will not touch each other. So due to positive charge, it will be separate. Due to negative charge, it will be separate. Exactly at the center, you will have the equipotential surface, because at the center, what will happen? You will get an equatorial plane, and on equatorial plane, you have an equatorial axis. Every point has the same potential. That's it, no? Right. I think current electricity was comparatively easy. Shall we move to the next chapter? That is, we'll see the questions from this. Drift velocity of electrons is due to the motion of which one? So read all the options. Tell me why each option is wrong in the first place. Repulsion of the conduction electron due to inner electrons of ions. Is there something like that happening? The motion of conduction electron due to random collisions. Is it because of the random collisions are they moving? No, due to the random collision, their initial velocity, average initial velocity will become 0. And random collisions are happening due to the thermal agitation, right? So what about C? The motion of conduction electron due to the electric field E. That is right. So let's see the fourth one also. Collision of conduction electron with each other. Not convincing. C. I think I've already given you the answers here, but read. Direction of conventional current. So if you see who's responsible for the conduction of charges, or what are the majority charge carriers inside a conductor? They are electrons. Electrons move from lower to higher potential, but the conventional direction of current is taken from higher to lower potential. So higher to lower, who move? Positive charges. So that is why the conventional direction is given as the direction in which positive charges tend to move. If the wire of resistivity rho is stretched to double its length, then its new resistivity will be. There is a wire of resistivity rho, it is stretched to double its original length, then its new resistivity. So it's become 4 times. Ana tappu. Read the question. Read the question carefully. What he's saying is right. Resistivity depends on the nature of the material. Why would it increase? It is the resistance that will increase. Subrajit, what you told is square of the value is for resistance. R is equal to n square times R dash. Okay. But resistance will become 4 times square. Okay. So resistivity, what will happen is no change. Be very careful. Why? What is the reason? It is independent of the length and area. It depends only on the nature of material. At the same time, it depends on the temperature that is present. You have this formula. Remember, rho is equal to rho naught into 1 plus alpha into delta T. Correct? So it is no change. Try this. A potential difference of 10 volt is applied across the conductor of resistance 1 kilo ohm. Okay. Find the number of electrons flowing through the conductor in 5 minutes. 2 minutes time, do it fast. Anybody with the answer? 1.875. 1.875 into 10 power 19. These many electrons. Is that right? So how to do this? Simple. So potential difference resistance is given. Whenever they are given, what is the first thing you need to do? Find the current. So I is equal to V by R, 10 divided by 10 power 3. So it is 10 power minus 2 ampere. Is that right? So find the number of electrons flowing through the conductor in 5 minutes. So time is given, they are asking the number of electrons. So apply the quantization of charge. So N into E divided by T is equal to 10 power minus 2. So N is equal to 10 power minus 2 into T is 5 minutes. 5 minutes is 300 seconds divided by 1.6 into 10 power minus 19. If I approximate this 1.6 to 1.5 for time being, okay, I can tell you what is the approximate answer. You will get somewhere around 200 or 2000, right? Correct? So how much are you getting? I hope this is clear. Approximately, this is not the exact answer. So what you guys told is right. 1.875 will be the exact answer. How to do this problem? So the plot shows the variation of potential difference across the combination of 3 identical cells in series. So when you connect the identical cells in series, what will happen to the EMFs in the first place? They get added, subtracted, multiplied, divided, what will happen? That depends on how you connect them. Positive of the first cell should be connected to, sorry, negative of the first cell should be connected to the positive of the second for them to get added. So, yeah. So here, one confusion I want to stress on this point. When we say series, right, people think that the EMF will always get added. Not necessarily. When you say cells are in series, what are the preliminary conditions there? It doesn't mean the EMFs get added. Rather, it actually means that the current across all the cells is the same. So wherever you see the word series, the first thing that should come to your mind is current is same. Okay, because in series also what can happen? They can get, if I connect two cells of same EMF like this, then what is going to be the net EMF? What is going to be the net EMF in this scenario? It is 0. Yeah, because if I take a resistor R, this will supply current I and this will supply current I. They both are being supplied in opposite direction. They get nullified, right? So, but still you can say this, the both are in series. So, since here it is a non-zero value, I am assuming that negative and positive are connected. Means the EMFs are getting added. Okay. So, be careful when you read a question. Across three identical cells in series versus current. What is the EMF and internal resistance of each cell? What is the EMF, guys? By now you should have found it out. What is the basic definition of EMF? So the graph is the variation across water, potential difference and current. So he is asking EMF across each cell. So what is the basic definition of EMF? EMF is the potential difference in, complete that statement, dash condition. In open condition, what do I mean by open condition? Current drawn by the cell is current drawn from the cell is 0. So when I say current is 0, when I say current is 0, observe the graph carefully. Can I say the coordinate of this point is 0, 6? Correct? So 0, 6 now current is 0, whereas the potential difference is 6, and this potential difference is the EMF. Right. So when this EMF is equal to 6 volt, that is the net value, then what will be the EMF across each cell? Is it convincing? Now they are asking what is the internal resistance across the cell. Sorry? So if you find slope, what will you get? So you find the slope of the graph. So this is 1, 1 ಇದೆ ಹೊರಡ 1 ದನ 1, 0. What is going to be the slope? 6 divided by 1. So it should be 6 ohm. Again, 6 ohm is the equivalent value. So what will be the individual value? Is the logic clear? How many of you did this?
Yes, sir.
See, this market is important. I've seen this question many times. Market is important. One last question. Given the resistances 1, 2, and 3, how will you combine them to get an equivalent resistance of 11 by 3 and 11 by 5? So logic is when multiple resistors are given to you, if you want a resistance value higher than all the resistors given to you, you need to connect them in series. If you want a resistance which is less than all the values given to you, all of them should be connected in parallel. But if it is a value intermediate, right, then you need to have a mixed combination. When you think of mixed, you need to find out which one to be connected in series and which to be connected in parallel. How to proceed? 1, 2, and 3 are given. If they ask you, you need a resistance whose value is greater than all the resistors. For example, LRG series connect, what will happen? 6 ohm. The 6 is greater than all the 3 resistors. 1, 2, and 3. Adhe mari LRG parallel connect something big. So 11 by 6 it is less than all the values. So 11 by 6 kuda varadu. Is it 11 by 6? All in parallel or 11 by 6 mixed combination. It will definitely be less than 1 for sure. A less than 1 ன்னு சொல்றேன்னா that is the least value that is possible. 11 by 6. 5 by 6 no.
6 by 11.
11 by 6 is greater than 1. 6 by 11. So 6 by 11 would have been the answer. So that is lesser than the least resistance that is present. But if you see the options that are given are 11 by 3 and 11 by 6. So for that, what should be the combination I need to use?
Sir, for 11 by 5.
11 by 3. Okay. So on the 1 and 2 parallel, எப்படி கண்டுபிடிப்பேன்? அதுதான் பண்ணக்கூடாது. அதுதான் லாஜிக். அப்புறம் என்ன இதுக்கு ட்ரையல் அண்ட் எரர்னா 10 ரெசிஸ்டர் கொடுத்த ட்ரையல் அண்ட் எரர் யூ டு 10C2 அது மாதிரி போட்டீங்கன்னா காம்பினேஷன் எங்கே போயிடுதா? Very good. That is what I was expecting. Denominator is 3. So when you take two resistors and connect them in parallel, you write them as R1 R2 divided by R1 plus R2. So R1 plus R2 are 3 varno in the denominator. So to get that 3, what should I connect in parallel? 1 and 2 I'll connect in parallel, and that will be connected in series with 3. Puri the logic, right? One and 2 you will connect it in parallel, and 3 in series with it, right? Similarly, if I need 5 in the denominator, that's rendu onnu daanda. 2 and 3 and 3 and 2 both are same. 2 and 3 should be connected in series with 1, right? So this you will get. Arvind, Purida. Yeah, those who are online, you understood?
Yes, sir.
Yes, good. So we'll stop with this, and the remaining problems we'll discuss tomorrow. We'll wind up this.